All right, we are continuing our section 8.3 on finding confidence intervals for population means. Really similar to confidence intervals for population proportions, it's just the formulas are a little bit different now. So again, we have to choose a simple random sample, some size n from a large population. We have an unknown mean. If we knew the mean, we wouldn't need to estimate it. For some confidence level, it's given by this formula right here. So remember that the x bar, that's your point estimate, right? X bar is going to be my point estimate. This whole thing right here is my margin of error. Okay, the critical value t star as well as the standard error. Okay, so the part that's inside here, this s sub x over the square root of n, that's your standard error formula for means. And we know t stars are critical value, and we have n-1 degrees of freedom. We just practiced finding that in the last video. So let's go ahead and jump in. If you look at the next example, we are going to be constructing and interpreting a confidence interval for means. All right. Anne and Tori want to estimate the average weight of an Oreo cookie to determine if the average weight was less than advertised. They selected a random sample. Sorry, technical difficulties. They selected a random sample of 36 cookies and found the weight of each cookie in grams. The mean weight was 11.3921 grams with a standard deviation of 0.0817 grams. Construct and interpret a 95% confidence interval. All right, 4-step process. We're still going through panic. So our first one is when we go through state, we have to talk about our parameter, okay? So I'm going to write out state. What are we going to do here? Well, what do we want to find? We want to estimate mu. And what is mu? It's the true mean of an Oreo cookie at a 95% confidence level. So what do we want to do? We want to estimate mu, which we need to talk about what that is. It's our parameter. It's the true mean of an Oreo cookie at a 95% confidence level. So that's our goal here. That's what we want to do. Now, this problem told you to construct and interpret the confidence interval. If they had said we want to, please estimate at a 95% confidence level, it's still the same thing. So it doesn't need to say the word construct. If it says estimate at this level, then you're good to go. All right, next comes our plan. As far as panic goes, this is where we assess our conditions and also name the interval that we're going to use. So we're going to construct a one sample t interval for mu as long as my conditions are met. So we will construct a one sample t interval for mu if my conditions are met. And we have to say all of this, right? I will look for that you say it's a one sample. I will look for that it says a t interval. I will look for that it says mu. These three things together tell you the method or the interval type that we're doing. So 3 conditions: random, normal, and independent. So starting with random, let's look back at the problem, and it said it selected a random sample. So I can just say cookies were randomly selected. So that takes care of that condition. Next condition is normal. So we have a new way of assessing normal now. We don't have to check to see if something's greater than or equal to 10. We have to look for the sample size and or the distribution of the population. So what was our sample size here? It was 36 cookies. According to the central limit theorem, that is a decent enough size to assume that we're approximately normal for our distribution. So we can say, because the sample size is large, and then just in parentheses I'm going to say, hey, 36 is bigger than 30, bigger than or equal to 30. We should be safe to use our t distribution. So even though it's a good enough sample size, we're still not going to use like the z normal distribution. We're going to use our t distribution. We still need to have this sample size be big enough, though. That's important. And if it's not big enough, we'll talk about that soon. Last one is what? Independent? Yes. Now, because I got my data from a sample, I need to check the 10% condition. The only time you don't need to check the 10% condition is if you get your data from an experiment. That's the only time you don't need to do the 10% condition. But since this came from a simple random sample, we need to say that we need to check the 10% condition. So, because I'm sampling without replacement, we need to check the 10% condition. So let's see, sample size is 36, so what's 36 times 10? 360? Safe to say that there are more than 360 Oreos in existence. I know because I ate that many over the weekend. So 360 is going to be less than 10% of all Oreos. So that one works as well. So my conditions have been met. Fantastic. So now we'll go ahead and do the do. Do the math. So general formula. You take, if I look from that other page, I've got this and that and the other. Running out of space. So let's make sure we can identify everything here. So x bar is my sample mean. The problem said the sample mean was 11.3921. I need to look up my critical value, so I'm going to do that here in a second. But then I need to multiply by my sample standard deviation, which was 0.0817 over the square root of 36. Alright, so here's where you either pull out your T table, right? That's that new table B we got the other day. Or you can use your calculator. So I'm going to show us both ways. So if my sample size is 36, that means my degrees of freedom is 35. Okay, my degrees of freedom is 35, and I'm looking for a 95% confidence. Now, this is that case where 35 isn't on my table. So in this case, we need to round down. So here's what I mean by that. Here's my beautiful table. There's a 40 and there's a 30, but there isn't a 35. So the closest if I go down is 30. And this is a 95% confidence, so I go up and see that my value is 2.042. And that's the value from the table. Now, that's using the table. If you want to be more, ooh, that's bad. If you want to be more exact, you can use your calculator. Just like we had inverse norm, there's also inverse t. So go ahead to second vars, and we're going to go to inverse t. Now, just like before, you have to put in the area. So you have to do a little bit of math. So 100 minus 95 is 5%. Half of 5% is 0.025. Sorry, my calculator's messed up. And now you do have to enter your degrees of freedom, which we said was 35. And you go down and figure that out, and it gives you, can't see it, negative 2.03, but again, we always use the positive value. So we're going to say 2.03, which was close to the table. So you can either use 2.042 from the table, or you can use 2.03 from the calculator. I don't care which one you do, as long as you show or say where it came from. Okay? So I'm just going to use the one from the calculator just to be even more exact, because that's going to be the more accurate one. There was a 0 after that. And then I just go ahead and figure that out. So in my calculator, I'll do 11.3921. I'll start with, subtracting first. I am using the wrong formula there. Times 0.0817 divided by the square root of 36. Follow along in your calculator too. Make sure you know how to do it. And I get a value slightly smaller than my x bar, which was what I want. So that's my lower bound. And then save myself some time. I'm just going to put that in my calculator again and just change it from a minus to a plus. And that gives me 11.4, let's say 2. So there's my interval. All that's left to do is to conclude, and we've been doing this since the first section. So we are Marshall. Now, conclude. We are 95% confident that the true mean weight of an Oreo cookie is between 11.36 grams and 11.42 grams. Okay. All right. Last example real quick. On the packaging, the stated serving size is 3 cookies. Yeah, right. Who only eats 3 Oreo cookies? Now, does the interval in Part A provide convincing... I have a laugh track today. Does the interval in Part A provide convincing evidence that the average weight of an Oreo is less than advertised? So, if they're saying for 3 cookies is 34, that would be, okay, 34 divided by 3 is 11.3 repeating grams per cookie. Now, was 11.33 in my interval? It was close, but it wasn't in there. So, because all of my plausible values in the interval are above that value, there is no evidence that the average Oreo weight is going to be less than advertised. In fact, there's actually convincing evidence that the average weight is greater than advertised. Alright, so that is an example of how we do a confidence interval for means. If our sample size is bigger than 30, now if your sample size is less than 30, you're going to have to do a little bit of graphing, and we're going to see that in the next video. So tune in to that.